Okay, so clearing up the for space para ma-continue natin siyang derivation nato, we have this figure naman, ba? So, this figure, this small segment, dili siya galihok. So, in essence, it obeys the laws of statics gyapon, ba? So, we can invoke the equilibrium equations na din rather diri. So, as to derive some relationships between naning mga kuan nato diri, kang between load, moment, and also kang shear. Now, although dili na kay ni siya kuan, but I would like to use summing up forces along the x is equal to 0. So, normal force is also equal to normal force. Okay? So, dili na kay nato siya concern. 0 is equal to 0 na siya. That is just so kuan lang, formality lang na kuan. Now, moving on to something medyo significant gamay, let's talk about equilibrium sa y direction. Now, summing up forces accordingly sa tuong kuan dinhi, y direction, we have v is going up, ba? V is going up. Now, aside from that dayon, na din tay kuan dinhi, W times delta x is going down. So, to just pick a side. Kani, para siya pong storya, going down yapon siya. Pick a side. Now, this is equal to kani. Diba? Oh, sorry. V and V, this cancels out, leaving us with just 0 is equal to W delta x plus delta v. Okay, I divide everything by delta x, and I will have w plus delta v over delta x. Ako siya labay dos pikas, and I will have delta v divided by delta x is equal to w. I will have this expression din. Now, sa nga na case, gusto ko mag-apply din ko na some theorems from calculus. I don't know, it's either kang Newton or kang Leibniz. I applied the limit theorem ani siya. Since delta x is so small, rather infinitesimally small, it's inching closer and closer to 0. So, I think it's only right that I invoke this theorem here, limit theorem, na may mo din siya og siya. Of course, what I do to one side of the equation, I do to the other pod kay para dili mao sab ang iyahang quality. Kani siya do labay ako siya, this becomes negative. Okay? So, this is negative w, and it is something like this na dayon, ba? Applying the limit theorem ani siya, it becomes, ako siya isulat diri pikas, kita siya. Okay? So, it becomes unsa? dv over dx. And that is equal to unsa? Wala man sad siya delta x sad, so consequently becomes negative w na lang dayon. Okay? Now, I'd like to do away with the negative sign. W is a variable, so it will change over time or unsa man na siya. Pwede siyang positive, pwede siyang negative, so why not ako lang na siya ignore. Okay? So, ana na lang din siya. So, to make it ko na lang. Now, ako ni siyang ikuan din diri, dula na ako ni siya, I will have dv w times dx. And I will, differentials. What do we do with differentials? We integrate them para may mo siya og function na sa din sakto. Applying the integral, this becomes v is actually equal to dx. Okay? So this is the relationship between shear and load. Okay? Now, what does this formula mean? This relationship mean? Okay? This means na So sir, si W encased under the integration sign. That's exactly correct naman, pero let's try to find a much more profound meaning and say, when you say a function is being integrated under sa kuanda na, it inherently means na this is B, this is X, and this is W. Ba? Now, I will have curve na siya W. Talk about calculus. Now, sige na case na yun, I can just say na lang din dara na W, that rather shear, is actually equal to the area under the curve of, the shear is the area under the curve of W, load. Okay? Area under the curve W. Area under the curve of load. Okay? So, muna siyang ibig sabihin na siya. When we solve for, natin ng graph ni W, we solve that area below siya na curve. Muna siya tumingon din dara na, that is shear. Okay? Shear is the area under the curve W. Muna siya yung fundamental relationship. Okay?